Okay, now let us look at the next question, which is on solar panels, solar power, and climate models. Okay, let us see how many marks does it account for. This is 2 plus 1, 3, 4. 4 plus 3 is 7. 7 plus 3, 10. Oh my god, it's too much. 10 plus 2, 12. 12 plus 4, 16. 16 marks it accounts for. Okay, so I think I can divide this once again into 8 and 2. 8 and 8, I think, right? Let me see. I'll first do it for 8. It's already for 6. Let me make it as for 8. Save this. 8. Okay. Put it over here. Bring this one to here. Right. Okay. So, open. Right. Let me start. Okay. Distinguish in terms of the energy changes involved between a solar heating panel and a photovoltaic cell. What is a solar heating panel? Solar heating panel is nothing but solar heating panel. These are 2 marks, right? This could be, so heating panel could be, what does it do? It converts solar energy to thermal energy. This is what it does. And a photovoltaic cell, what does this do? Photovoltaic cell does solar energy. It converts solar energy. Don't write arrows like this. You should write solar energy converts solar energy to electrical energy. This is what you should write. Okay. Then state an appropriate domestic use for a solar heating panel. What is the use of it? You can use it to heat water. Like a geyser, right? Or you can use it for heating the water in a pool, right? You can use it for any other purposes. 1 mark, so 1 application is fine. Photovoltaic cell to generate electricity. Examples is making use of solar panels. You can use this one here. Okay, or maybe you can use it to run domestic devices like bulb, TV, radio, etc. Charging, right? Charging a mobile or whatever it is, you can use it for all this, right? Next, the radiant power of the sun is 3.9 into 10 to the power of 26 watt. Power is given. The average radius of the Earth's orbit around the sun is 1.5 into 10 power 11 meters. Okay, so this is the sun over here. This is the Earth which is orbiting here over here, and this distance is already given to us 1.5 into 10 to the power of 11 meters. Okay, the albedo of the atmosphere is 0.3, and it can be assumed that no energy is absorbed by the atmosphere. Okay, show that the intensity incident on a solar heating panel at the Earth's surface when the sun is directly overhead is 966 watt per square meter. So this is what is the question being asked. So how do you do this? Now, see, when you say about the intensity, average intensity received by the sun. So what does the sun do? Sun is giving out radiations in all directions. That means a small part of the radiation reaches over here, and this should be equal to, okay, the total power emitted divided by the surface area of the sphere, which you construct using the distance as a radius, right? Because you will get here, everywhere you will get, but Earth is only at this point, right? So therefore at one point, we'll assume Earth is a point object. At one point, what is the amount of power that I am receiving, which is nothing but intensity is given by power divided by 4 pi r square. Okay, and at the same time, so now let us see what is that we get over here. So this should now be equal to 3.9 into 10 to the power of 26 divided by 4 pi into 1.5 into 10 to the power of 11 whole square. Okay, let us calculate this value. Where's my calculator? Calculator is here. Okay, so this should be 3.9 divided by, I'll do one thing. First I'll find the denominator, then I'll go for the numerator. 4 star 3.14 star 1.5 star 1.5. I've done this. I get some value 28.26. If I take the reciprocal of this one, so I'll do 1 by 28.26. So this goes up upwards, multiplied by 3.9, multiplied by 3.9. When I do this, only the numbers I have calculated comes out to be around 0.138, but powers I have not yet done anything. So let me do the powers also. 10 power 26 numerator mein, and then here you have 10 power 11 whole square will be 10 power 22. When it goes upwards, it becomes minus 22. So it will be 0.138 into 10 to the power of plus 4. What is the full number here? 0.13800. Okay. So this should be around 1380. 1, 2, 3, 4. Okay. 13130 so watt per square meter. What is this now? This is the amount of intensity of the radiation falling on the Earth's surface. Okay. This is what we got. Now, out of which, what does it say? It says the albedo of the atmosphere is 0.3 and assume that no energy is absorbed by the atmosphere. What do you mean by albedo? Albedo is nothing but I scattered divided by I incident, which means whatever rays of light comes and hits on the Earth's atmosphere, the atmosphere does not absorb anything, but instead it reflects back. How much does it reflects back? If you give 100 units of energy, it gives back 30 units of it. That's what it means by 0.3 over here. So which means only 0.7 comes and lands onto the Earth's surface, right? 30% is already reflected. Okay, whatever comes over here, it is something like you have a set of objects with you, you throw it to the screen, there's a possibility a few of them will penetrate through it. You have a, let us say, not this screen, you have something like a tissue paper. Okay, you have a tissue paper as a screen, you take some 100 marbles and throw it across. 30 marbles might get reflected, 70 marbles might break the paper and get outside, right? So therefore, so you can say 0.7 times this value 1380 will be your intensity which is falling on to the Earth, which should now be equal to, how much is it? Let us calculate this also. So should be 1380, right? I'll cancel this. 0.7 star 1380, which will be 966. So 966, what is this now? Watt per square meter is the intensity of solar radiation or energy that falls on Earth's, which one? Not atmosphere, surface. You got this now. Okay, what is the question? Read the question again. Show that the incident intensity on a solar heating panel. Where is the heating panel kept? It's on the Earth's surface, right? So whatever falls onto it is equal to so much. Okay, you got this. Done. So 3 marks. How is the 3 mark been awarded? First mark is awarded for this one. Okay, very important. Second mark is getting something like defining the value of alpha and what does it mean and why did you take this one? Justification. The last mark is the calculation. Okay, so those 3 marks have been divided like this. Next, show using your answer to see that the average intensity incident on the Earth's surface. Okay, what do you mean by Earth's surface? See, this is my sun. This is the sun and this is the orbit of Earth. Now the orbit of Earth is so small over here, very tiny surface here, right? So therefore, now when you look from the sun over here, see for example, if you look at me, okay, so what can happen is, according to you, for my face, so though I am my face looks like, my head actually looks like a sphere over here, a complete sphere. But if you look from the video from there, you will be able to see just as a circle over here, right? So as a result of it, the intensity, the power that gets absorbed on the surface is only a disk over here. It's only a disk for the sun over here. So therefore, the intensity that you receive on the Earth is nothing but, see, intensity that you got here is 966. This intensity multiplied by the area of the disk. Okay, it is the area of the disk. If that is the sun, it's the area of the disk over here. Area of the disk is into pi r square will give me the power. What is this power? The power which can be seen to be falling onto the Earth over here. Okay, Earth which is facing the sun. Now, but if I ask you what is the average intensity, how is the Earth looking at? Is it just a circle? It's not a circle. It's a full sphere, right? So therefore, so what should I do?